I got it. Got it. Got it. Just checking my playlist. Uh, what up? 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 All right. Just making sure everything's working. All right. Welcome to Mondays. Oh shoot, it is actually Tuesdays. Live homework session. I am going to review a lot of calculus prep today. There are a few questions that students had sent and students wanted me to review. So today's going to be a huge calculus prep of just a bunch of problems for you to continue getting ready for what is known as calculus. Okay. I think I am ready to go. I have everything set up. And don't forget, if you ever have any math questions, you could always send them to me, following me on TikTok or Instagram, or going to theveganmathguy.com. All right, let's already get started. Let's go ahead and go to that very first problem. So it looks like problems A, B, and C are asking us to find the y-intercepts, the x-intercepts, and the y-intercepts of each function. So let's just start off with the y-intercepts first, and then we'll talk about the x-intercepts. So for part A, we are trying to find the y-intercepts, and every time you want to find the y-intercepts, you want to make sure that you set x equal to 0. So let's go ahead and do that now. So y equals, and then we're going to go ahead and substitute 0 for x in there and just simplify. So it looks like 0 over 1. So the y-intercept for A is going to be 0, comma 1. And then if we want to find the x-intercept, this is what we have to set the y equal to 0. So we will have 0 equals x over 1 minus x squared. Now, this one's going to be tricky. Whenever you are trying to find the x-intercepts, all you have to do is set the top equal to 0. The reason being because if you're looking at the equation that I have here, all I have to do is multiply the 1 minus x squared to the other side. And what will cancel out? Well, denominator cancels out on the right side. And on the left side, we just get 0 is equal to x. So we have the top equal to 0. And in this case, it's fairly simple. I mean, x is equal to 0. There's really nothing else that we need to add there. So the x-intercept is going to be 0, comma 0. So y-intercept 0, 1, and x-intercept 0, 0. Let's go ahead and go to part B. Now, part B, as I write it, there's a possibility that maybe the bottom and the top can factor out, and we can make something of that. Let's see. It doesn't look like we can factor anything out on the top, and we can't do anything on the bottom so far. The top will probably factor out, but what I'm trying to get here is that there's nothing that cancels out, meaning there's no discontinuities. So as we mentioned, if we're trying to find the y-intercept, don't forget, let's go ahead and make x equal to 0. So then we have y equals, and go ahead and plug in 0 for every value of x that you see in the equation. 0 squared plus 0 plus 1. Okay, it looks like 1 over 1. Nice. So the y-intercept is going to be 0, comma 1. Awesome. Okay, I feel like I need to make some space here. So let's go ahead and find the x-intercepts. And if we want to find the x-intercepts, don't forget, for the x-intercepts, this is where we make y equal to 0. So 0 equals 2x squared minus 3x plus 1 over x squared plus x plus 1. And in this case, just like the previous problem, you can go ahead and multiply the denominator to both sides. But what's going to happen again is you're just going to left with 0 is equal to 2x squared minus 3x plus 1. So like I mentioned, if you're trying to find the x-intercepts, all you have to do is really set the top equal to 0 and find out what values make that equal to 0. We have a quadratic in this case, so it looks like we are going to have to factor out. There's many different ways of doing this. I'm just going to use the diamond method. So I'm going to multiply 2 to 1. So I'm looking for two numbers that multiply to 2, add to -3. Looks like it's -2 and -1. So if I'm trying to factor this out, let me kind of move this up a little bit. Now my two values that I'm going to rewrite -3 with is 2x squared minus 2x minus 1x plus 1. And in order to factor this, one last step is to group these two. So let's see, I can factor out a 2x from the front, and that's x minus 1. And then let's factor out a -1 from the second group, and that's x minus 1 as well. So I have 0 is equal to 2x minus 1 times x minus 1. And don't forget, we have a quadratic, so we factored. So now when we have these two factors or factored values, we have to make sure we set them equal to 0 and solve for x. So for the first one, 2x minus 1 is equal to 0, 2x is equal to 1, x is equal to 1/2. And now the last one, x minus 1 is equal to 0. Well, it's pretty simple. Just go ahead and move the 1 to the other side. X is equal to 1. So those are two x-intercepts for part B. All right, so now let's go ahead and do part C. Let me just write that out a little bit. Okay, so y-intercept, as you can imagine, same step. Go ahead and make x equal to 0. So just think of always the opposite. If you're trying to find a y-intercept, make x equal to 0. If you're trying to find the x-intercepts, make y equal to 0. Okay. So let's go ahead and do that now. So y equals e to the power of 1 minus 0 plus 2. Let's simplify that. Y is equal to e to the 0 plus 2. E to the 0 is 1. So we have 1 plus 2, which is 3. So my y-intercept is going to be 0, 1. Hopefully I have enough space to write everything out. If we're trying to find the x-intercept, remember as I mentioned, we're going to make y equal to 0. So I have 0 equals y, e to the 1 minus x plus 2. Okay, I already know this is not going to have a solution. One way of thinking about this is a exponential function. It doesn't have it doesn't touch the x-axis. It actually has a horizontal asymptote at 2. But let's just say we didn't know how the graph looked. We're going to quickly find out that there's no solution to this. So we're going to move the 2 to the other side. Subtract the 2 to the other side to get -2 equals e to the 1 minus x. Okay, and now what we're going to have to do, because we want to cancel out that e, you want to bring those exponents down. We're going to take the natural log of both sides. Now on the right side, still no harm in that. It's just 1 minus x times ln of e, which is going to be 1. But look at the left side. We have natural log of -2. That does not exist. There's no negative values that exist within the logs. So right away on the left side, there's no solution. It just doesn't exist. Therefore, the right side is not going to exist either, meaning that there's no x-intercepts. Okay, so once again, the natural log cannot exist. There's no solution. Therefore, the right side is also not going to have a solution, because they're supposed to be equal to each other. All right, guys, that was part A, B, and C to find the intercepts, x and y intercepts. Let's go to the next slide. Oops, went a little too fast there. Okay, so this is all just about rationalizing, and it's going to be helpful when you start taking the limits of things, or when you're trying to solve the limits. So this is why the student who sent me this for some calculus prep, this is why these problems exist, because they're going to want you to practice rationalizing the denominator there. Okay, so I have x minus 1 over root x minus 1. In this case, because they want you to rationalize the denominators, they make the directions pretty clear. You're going to multiply by the conjugate to the top and the bottom. Now, how do we find the conjugate? How did I get this value? If you look at the denominator here, the conjugate is simply the same equation or the same expression, but it's going to be opposite signs. So instead of a -1, it's going to be a +1. And so all you have to do in this case, I'm just going to purposely write, let me erase these things. I'm going to purposely write some parentheses in each and every one of these. The reason being is because when I'm trying to solve this, I'm going to have to go ahead and FOIL. So on the top, how do I FOIL? First, outer, inner, last. Some people call that distributing. It's the same thing. So that will give us x root x plus x minus root x and then minus 1. Okay. Nothing seems to cancel out. Everything kind of just stays like that for now. So I'm not going to do anything just yet. And on the bottom, again, I'm going to FOIL. So that's going to give me x plus root x minus root x minus 1. Look at the bottom. Those root x's cancel out. No surprise there. The reason why we're doing or we're rationalizing the denominator is so that these radicals can cancel out. Okay. So let's go ahead and let's rewrite this. Let's see, on the bottom, I'm still left with x minus 1. I think that's just a good expression to leave it as. And on the top, again, there's nothing to simplify. So we're just going to leave it like that. That is me or us rationalizing the denominator. Okay, let's go to number 6. Be very careful here. Number 6, because if you think you want to rationalize the denominator, you are incorrect. Because if you read the directions as I'm writing this, they are asking to rationalize the numerator this time. Okay, so think about this. We're rationalizing the numerator, meaning that we want to somehow get rid of the radicals on the top. So what do we multiply the top and the bottom by? It is its conjugate. And what is that? As I mentioned in the previous problem, it is the same expression, but the sign changes. Okay. And again, I'm just going to have to go ahead and put some parentheses here. There's so many like binomials being multiplied here. I'm just going to have to use FOIL. Okay. At any time, if you feel like pausing the video and trying to solve this on your own, please feel free to do so. But think about this. We're going to FOIL this. Let me just go ahead and draw those arrows signifying what I'm multiplying. Some people call this FOILing. Others call this distributing. It's the same thing. Keep that in mind. So let's see. The first on the top, we have x plus root x plus h minus root x plus h, and then minus x plus h. And I put a parentheses at the end, minus x plus h, because I'm subtracting both of, or I'm subtracting this sum. So eventually I'm going to have to distribute that negative sign. So I have to just make sure that I put a negative sign in parentheses x plus h whenever you have more than one expression in that you've multiplied or that your answer is. Okay, and on the bottom, let's see, it looks like, geez, I'm just going to leave that factored out for now. Don't really want to distribute just yet. And you're going to see why. This is something that you learn in calculus, is that when you're trying to rationalize things, the bottom usually can stay as it is, or the top, whatever you're not trying to get rid of, because things are going to cancel out. You'll see in a second there. Okay, back to the top. Hopefully you can see that the radicals cancel out. And then as I rewrite this, I'm also going to distribute that negative sign. So I have x minus h all over 2h root x plus h root x plus h. Okay. And what do you know? Those x's cancel out. So I'm just left with negative h on top. Now, just for the sake of having some space here, I have the negative h on top by itself. Hopefully you can see that h that I have there on the bottom that I've highlighted. Guess what? We can cancel that out. So then I'm just left with a -1 on top, and then the h has gone away on the bottom. Okay, I'm gonna try to annotate here. I want to move and have enough space for me to write at least the end of our problem here. Okay, there you go. Looks good. So now what does this become? It's going to be -1 over 2 root x plus h times root x plus h. Okay. And again, this is something that you see a lot of in calculus. In the very beginning stages of calc, you start taking limits and Simplifying this is going to be very, very important. Knowing how to rationalize the denominator is going to be key. Okay, let's go to number 7. So we want to rationalize the denominator. So we have root x squared plus 1 minus root x. There's not much to this. I think all we have to do now is multiply the top and the bottom by root x squared plus 1. Oops. Plus root x. Don't forget, it's the same expression, but opposite signs. And then on the bottom, I have to also multiply that. Now, why do we do this? Well, if you're multiplying the top and the bottom by the same thing, you're basically multiplying the entire expression by 1. Okay, so on the left side, there's no fraction there, so I'm just going to go ahead and recreate that. I'm going to put an over 1 so that I can have something to multiply that denominator by. Okay, back to our foiling. First, outer, inner, last. And this becomes x squared plus 1 plus root x squared plus 1 minus root x squared plus 1, and then minus x all over. And then this expression, root x squared plus 1 plus root x. Okay, cool. Looks like hopefully some things cancel out. So root x squared plus 1. On the top, it looks like just the radicals cancel out. I was really banking or hoping that those x squareds and the x cancel out, but that's not, I cannot do that because they're not like terms. Okay, so I'm left with x squared, just to rewrite this, minus x plus 1 all over, and then this value, x squared plus x, or root x squared plus x, root x squared plus 1 plus root x. There's so many roots and things to say as I'm writing this. Yeah, this is an interesting question. I think this is more of an exercise because technically the bottom has a radical, so we would have to rationalize the denominator. But then we're going to end up with the same equation that we were given in number 7. So I think for number 7, they just really wanted you to practice rationalizing the expression, which we did. All right. And if I got anything incorrect, if you have an answer key to this, or if someone feels that, they saw something or a different method, feel free to let me know in the comments. Yeah, and criticize me. Guys, I am not very smart, so please correct me if I get things wrong. Okay, let's go to this next problem. Number 8, solve by using the quadratic formula. Okay. And you might think, oh gosh, this is going to be algebra or algebra 2. Why do I need this in calc? Trust me, very, very helpful, especially when you start doing something called derivatives and you're looking for critical points. But again, just keep in mind, quadratic formula is always going to be helpful and essential in almost any level of math. Okay, so if we're trying to use the quadratic formula, we're going to have to make sure that we set the equation equal to 0. So let's bring the 1 to the other side. So x squared minus 6x plus 1. And if you don't remember the quadratic formula, I'm about to write it. Feel free to pause the video so you can try to memorize it yourself. If not, here it is. Negative b plus or minus root b squared minus 4ac all over 2a. Okay. And if this is, this is calculus or calculus prep, you should know that your a value is 1, your b value is negative 6, and then your c value is negative 1. Okay, here we go. So x is equal to negative 6 plus or minus negative 6 squared minus 4 times 1 times negative 1 all over 2 times 1. Okay, I think I'll have enough space. Let me just move this up to the top. So 6 plus or minus root 36 looks like plus 4 all over 2. Simplifying the radical a little bit further, it becomes root 40 over 2. And root 40, I believe, can be 2 root 10. Why is it 2 root 10? Just keep in mind that root 40 is the same thing as root 4 times root 10. And root 4 is 2, so root 10. Okay, back to our problem. The whole thing is being divided by 2, and now I can divide both terms divided by 2. So it's like, what I mean by that is if I separate this, make this 6 over 2 plus or minus 2 root 10 over 2, guess what? That can simplify even further as 3 plus or minus root 10. And those are our 2 values. Okay. Number 9, that one's interesting. So we want to, they set this equal to 0. So this is really, they're asking for the x-intercept. So a few things. Hopefully, let me just, actually, I think it's big enough that you can kind of visualize this. Hopefully you can see that every single term here has an e to the x plus 1 in common. Well, on the top, since they have one in common, at least one in common, I'm just going to go ahead and factor that out. So I factor out an e to the x plus 1 from everything. And what does that leave me? So inside I have 3x times 3e to the x plus 1 minus 6x squared e to the x. Okay. And now all over e to the x plus 1 to the power of 4. Now what does that do? Well, on the top, 1 e to the x plus 1 cancels out. And on the bottom, since there's 4 of them, now there's only 3. So let's just go ahead and rewrite this. I have 3x e to the x plus 1 minus 6x squared e to the x all over, it looks like e to the x plus 1 cubed. And again, this whole thing is set equal to 0. It looks like because they are asking for a graphing utility, this is interesting on how they want you to actually solve this. If they want a graphing utility, it looks like you're going to have to use Desmos or use a graphing calculator. But again, because this is set equals to 0, it's another way of saying, find the x-intercepts. And if you think about it, I'm multiplying the bottom to the other side. So this is just 3x times e to the x plus 1 minus 6x squared e to the x is equal to 0. So I'm really trying to solve when this is equal to 0. Before I do anything, I'm just going to distribute the 3x to the parentheses so that we got 3x. Let's continue with yellow. 3x e to the x plus 3x minus 6x squared e to the x is equal to 0. And honestly, it doesn't look like we can do much here. I'm trying to just rewrite this, and I'm trying to see if there's even a possibility where I could just use like some sort of quadratic formula, or there looks like there's nothing else. So in this case, it looks like you're just going to have to use Desmos or a graphing calculator. I'm using Desmos just to graph it. Maybe I can even show you over here. Let's go ahead and show Desmos real quick. So if we want Desmos, here we go. Okay. So let's go ahead and just graph this. What was the equation in question? It was, oh gosh. So I'm trying to show this on the screen and it looks like I erased it. But if I recall, it was 6x squared e to the x plus 3x e to the x and then plus 3x. Whoops. And even as I'm writing it on Desmos, 3x squared e to the x plus 3x e to the x and then plus 3x. Here we go. Okay, it looks like, so we graphed it. It looks like the only solution when this is set equal to 0 is going to be 0 itself. Kind of should have known that. You could just factor out an x from everything, but because they asked for a graphing calculator, you graph that and you find there's one solution and one solution only. So it looks like it's x is equal to 0. Okay, cool. That's how we use graphing utilities. Awesome. So it looks like everything had an x in common. Perfect. So we can just go ahead and say that. So back to number 9. The important thing to remember here is that you want to set the top equal to 0. You want to factor out as much as you can. And from there, you can use a graphing calculator, or in this case, you could have used some common sense and factor out an x, and you could have gotten that x is equal to 0. Okay, let's go to number 9. Oh, that was number 9. Let's go to number 10. So it looks like they want you to expand logs. So let's go to part A. Let's go ahead and rewrite this. Hopefully, by now we can remember our properties of logarithms. Okay, We have two things being divided here, so we can rewrite this as a difference of the two terms. So I have the numerator log of x squared plus 1 minus log of root 3xy. Okay. Here's a common mistake that a lot of us can do. This x squared plus 1, just because it's being added, we might be tempted to write it as like, log of x squared plus log of y squared. Incorrect. That cannot happen, because the only time we could actually use that property is if the things were being multiplied together. And in this case, it's x squared plus y squared. It's just being added together inside already. We cannot use any of the properties, because the properties tell us that it's only if it's multiplied, divided, or if you have a power by itself. So in this case, that first expression, or the first term, can be written just as it is. We're not going to do anything to it, but let's look at that second one. Okay, we have a root. One of the first things to just keep in mind is that we have a root. So before I even do anything, I can rewrite it. Keep in mind that this is 3xy to the power of 1/2. So the whole thing has a 1/2 power. So now what I can do is I can move the 1/2 down. I can use that property of logarithms, and we get 1/2 log 3xy. And we might think we're done, but that second expression, this is what I was just talking about. Because everything is being multiplied, we can rewrite the whole thing as a sum. So the first expression, log of x squared plus y squared, nothing else that we can do there. But then we have minus 1/2. And actually, yeah, I can just do this. Log of 3 plus log of x plus log of y. And notice how we were very careful with that 1/2 on the outside, because the 1/2, it's being subtracted, but also 1/2, it's being multiplied to everything in the log. So then my final step is to write it as log x squared plus y squared minus 1/2 log 3 minus 1/2 log x minus 1/2 log y. Okay, that's part A. So now let's try the second part, part B. As I write it out, hopefully you can kind of already see that these things are being divided. So what do you know? We're going to rewrite this as a difference. So natural log of 9x squared y cubed minus natural log of z to the 4th. Okay, this is exciting because both terms could actually be simplified. The first one, you have things being multiplied together. So we can rewrite it as natural log of 9 plus natural log of x squared plus natural log of y cubed. And then that second one, there's nothing else there except the z, but that second term has to the power of 4, so we can take that 4 and use a property of logs to bring it down. So we have minus 4 natural log of z. But wait a minute, Miguel, what about these other two? You're absolutely right. The x squared and y cubed, those also have powers. So for each power, we can use the property of logarithms and put them on the outside. So then now we have natural log of 9 plus 2, natural log of x plus 3, natural log of y minus 4, natural log of z. There it is. There you have it, ladies and gentlemen. That is the expanded natural logarithm. I mumbled that, natural logarithm. Oh goodness, it's 7 in the morning here on my end. I thought it was going to be a little warm. But it's kind of cold today. It's like 50s, and I'm just wearing a t-shirt. Should have worn a sweater in my room. All right, guys, here we go. So for number 11, they give us the equation for the volume, and they want us to solve this for V. So they want us to isolate V. Wait, find H in terms of V. Oh, I see what's going on. Never mind. They give us two equations. So they tell us that H is equal to, they give us two equations. A little interesting here. Honestly, we just kind of like switch gears, if you will. Okay, so we have the equation for the volume, which is 4 pi, or V. We actually don't know what this is. 4 pi squared r cubed, and then we have H, which is 4 pi r. So they want us to find H in terms of V. And you might think, well, I already have H. It was given to me, 4 pi r. And you're absolutely right. But what they want us to do is they want this to be in terms of v. So what we have to do here with this equation is we have to isolate the r. The reason being is because once we find r, we're going to substitute it into the equation h. Let me show you what I mean. If we're trying to solve for r, that would mean that I should divide 4 pi r squared to the other side. So that's going to give me v, oh, let's continue using green. V over 4 pi squared is equal to r cubed. And then the last step is to take the cubic root of both sides. So that we have cubic root of v over 4 pi squared is equal to r. Okay. And so this value that we have, this value is going to go in for our r in that equation. Okay. So hopefully I have enough space. I'm just going to kind of take this equation and I'll take it on the right hand side here. So h is equal to 4 pi. But then now I'm going to go ahead and plug in that equation for r that we found. So this is going to be cubic root of v over 4 pi squared. Okay, I don't know how simplified they want you to do this, but for the most part, I think because this is a calc practice, they really just want you to understand just the methods here. There's not much you can simplify. If you will, actually, just one step, I guess something we could do. Actually, no, I was going to say we can take the square root of this denominator, 4 pi squared, but this is a cubic root. So we don't even have we don't know what the cubic root of 4 pi squared is. So I would just leave our expression, our equation that we have as it is. Okay, number 12. Number 12 is to divide x squared minus 6x plus 11. And you want to use long division. Oh boy. Okay, x squared minus 6x plus 11. Honestly, if this is calc prep, a lot of the times you don't use long division, you're going to use synthetic. Your teacher must just want to be, a little intense today. Okay, so whenever we're trying to find, whenever we're dividing this using long division, you want to ask yourself, what can I multiply to this x to get the x squared? So if you think about division, like how many times does x go into x squared? That's a question that we're trying to answer. And what is that? Well, if it's just x, I think that's all I need. So it's just x. And now that I have this, if you recall from like 4th, 5th, 6th grade math, we had to multiply the x times the divisor. So that's going to be x squared plus x. And then don't forget that we have to subtract this. Okay, so let's see, x squared minus x squared, that cancels out. And then negative 6 minus x is negative 7x plus 11. And now you got to ask yourself again, what can I multiply to the x to get negative 7x? In other words, how many times does x go into negative 7x? And that's going to be negative 7. And again, we multiply the negative 7 to both terms. Hopefully this is coming back. You hardly use long division. I think in class, your teacher might just say, you know what, just go on and do synthetic. Okay, so negative 7x minus 7. Don't forget I'm subtracting these values. So it looks like the negative 7x plus 7x is going to cancel out. And then I'm left with 11 plus 7, which is going to be 18. I have a remainder. So my answer is x minus 7 plus 18 over x plus 1. Okay, that was long division. And I'm telling you, I have a feeling you won't use long division. I think it's just going to be synthetic. On to the next one, completing the square. Gosh, I hate completing the square. And I'm going to say this, and I'll say it again. Completing the square is the worst. It just takes too much time. It's so annoying. Just dumb, especially for calculus. Why in the world? Why do we care about completing the square? It makes no sense. But anyway, here we go. Remember, whenever we're trying to complete the square, one, you have to make sure your leading coefficient is 1. It's good to go. So in this case, it is. And then you take your b value and you divide it by 2 and you square it. In this case, your b value was 2. So you're going to take the 2, divide it by 2 and square it. That happens to be 1. Okay, so I have x squared plus 2x. And then I have to introduce that plus 1. And then I still have plus 7. But because I introduced the 1, I have to make sure I subtract the 1 on the other side. Now you might think, well, the 1s and the 2 1s cancel out. What's the whole point? You're absolutely right. It's not going to make any sense right now, but the reason for that is because you need to now factor that new trinomial that we have. That's what we introduced. That's the whole point of completing the square. So two numbers that multiply to 1, add to 2. No surprise here that it's x plus 1 times x plus 1. But I'm just going to rewrite it as x plus 1 squared. That's the whole point of completing the square. So then we have plus 7 minus 1, so that's just 6. And we've successfully completed the square. Okay. Let's go to the next one. Part B, so 2x squared plus 2x plus 11. So in this case, hopefully you can see the leading coefficient is not 1. So we need to factor that out. Okay, so that's going to become 2 times, oops, let me just continue writing in yellow. I meant to do that in yellow, but for some reason, it doesn't want to show in yellow. So 2, there you go. X squared plus x. And notice that I'm not factoring out a 2 from that last term. We don't want that. We just care about the 2 terms, the a and the b values, if you will. So now when I want to complete the square, I take my b value, which in this case is 1, divided by 2 and square it. And that becomes 1/4. And this is just, oh God, why I hate this so much. So I have 2 on the outside and then x squared plus x plus 1/4. And then plus 11. And technically I introduced the 1/4 inside though. So if I distribute the 2 times 1/4, that's 1/2. That's actually what I introduced. So I need to make sure that I only subtract the 1/2 on the other side. Okay. If you remember completing the square when I'm trying to factor this, if you're trying to think of two numbers that multiply to 1/4 and then add to 1, that value will always be this. Let me go ahead and highlight it in blue. That's, or in this case, green. That's always going to be 1/2. 1/2 multiplied by itself is 1/4. 1/2 added by itself is 1. So then now we have this factored term 2 times x plus 1/2 squared plus, and then I have to combine the 11 minus the 2. I can just get common denominators, and I believe that's 21/2. That's completing the square. So annoying. Like, why? It doesn't matter. We're working with fractions here. Just, annoying. Okay, let's go to part C. Y squared minus 5y plus 1. Well, in this case, luckily for us, there's nothing in front of the y squared, nothing in front of the a value. So we are good. We can just take the -5, divided by 2, and then square it. And if you can tell, that's just something that's super annoying. 25/4. So then we have y squared plus 25/4. Or minus, I'm sorry, minus 5/2 y plus 25/4 plus 1, and then minus 25/4. Okay, so we're trying to factor this polynomial out. What two numbers multiply to 25/4 and add to -5/2? And as I mentioned, we don't really, I don't even know how you will find this unless we knew right away. And remember, I mentioned that is the value inside this parentheses. This is the value that I divided by 2 and squared it. So just that value that we divided by 2 and -5/2, that's our term. -5/2 times -5/2 is 25/4. And if we divide that, and if we add that together, it should be -5. And I realized I wrote my equation wrong. Let me just go ahead and rewrite it now. So this is just a -5. So what two numbers multiply to 25/4 and add to -5? That's -5/2. So now I have y minus 5/2 squared, and then I can just combine this, and I believe this is -21/4 if I get common denominators. That's completing the square. Okay, let's go to the next one. All right. Solve for the following equations over, oh, geez. Okay, so hopefully by now, this is no surprise, because if we're trying to, or if we're in calculus and we're trying to solve these equations, you should know your unit circle by now. Okay, so 2 cosine of 2x is equal to 0. So 2 cosine of 2x is equal to 0. So first thing that I'm going to do is let's divide the 2 to the other side and get 0. So now this is the tricky part. There's something inside the cosine. So first, I'm just going to treat it like, cosine of A. What values of A make this equal to 0? Well, there's a few terms. It looks like it can be pi over 2. So A can be pi over 2. It can be 3 pi over 2. It can be, if I continued, 5 pi over 2, 7 pi over 2. You notice that it goes on and on and on. Okay, but I wrote a few extra because of that 2x, because right now these are not just the terms these are the terms in the unit circle, but the value inside the cosine was 2x, so it's being affected a little bit. So let me just go ahead and rewrite the A. Now this is 2x equals pi over 2, 3 pi over 2, 5 pi over 2, and then 7 pi over 2. So now let's go ahead and divide everything by 2. And we get x is equal to pi over 4, 3 pi over 4, 5 pi over 4, and then 7 pi over 4. Okay, you notice that once I divided them by 2, all these values are inside one revolution of the unit circle. But in the top, all they said is they just want the values between 0 and pi. Well, let's see. Back to our values over here. Pi over 4 is one of them. 3 pi over 4 is one of them. And then all the other ones, 5 pi over 4, 7 pi over 4, are already too much. They're not in the domain. So the only two values that we have that make this true is pi over 4 and 3 pi over 4. Okay, let's go to part B. 2x and natural log of x plus x is equal to 0. Well, this is already equal to 0. So I would always just suggest, let's go ahead and check. Let's graph or factor something out. It looks like we have an x in common. So we have x times 2 natural log of x plus 1 is equal to 0. And now we have two things being multiplied together that make it equal to 0. So just set both of them equal to 0. Okay, so it seems like we already have our first equation, x is equal to 0. We know that's one of them. And in the second part, let's go ahead and try to isolate the natural log. Move the 1 to the other side. So 2 natural log of x is equal to negative 1. Divided by 2 natural log of x is equal to negative 1/2. And then we're going to go ahead and take the e to both sides. And then so x is equal to e to the negative 1/2. We are good with that. That is our answer. Okay, cool. Let's go to the next one. So let's go to C. So 2e to the 2x plus 3x e to the x is equal to 0. Ooh, this is interesting. So there's an e to the x, but I don't think we can factor that out. I mean, I guess technically we could factor out an x, an e to the x from both values, and that gives us, let's see, what would that give us? It's going to give us 2 e to the x plus 3x is equal to 0. Okay, not bad. So two things being multiplied together that make it equal to 0. So the first one could be 0, or 2e to the 3x, or 2e to the x plus 3x is equal to 0. Interesting. Okay, well, the first one, we can take the natural log of both sides, but you're going to run into a problem. We have x is equal to natural log of 0. That can't work. So we know that can't exist. Now, the only option that we have is 2e to the x plus 3x is equal to 0. And they did ask us to use a graphing utility. I believe it says that we can use a graphing calculator. So I'm going to go ahead and do that. Before I even finish, I'm going to graph this. Wow. And there is going to be a solution. Let me just go ahead and show you what would happen. So that's the graph of the function that we were setting equal to 0. And we're looking for an x-intercept. And it looks like it's this value, negative 0.433. So let's go back to our problems that we had. So negative 0.433, that's the only solution to part B. Or to part C, my bad. That's what happens when we switch screens and then everything gets erased. So x was equal to negative 0.433. All right, that was part C. Let's go to part D. Interesting. 4x cubed minus 12x squared plus 8x is equal to 0. Okay. So let's go ahead and factor out an x from everything. That gives me 4x squared. Actually, we can even do something further. We can factor out a 4x. So let's go ahead and do that. 4x. Let's see, 4x times x squared minus 3x plus 2 is equal to 0. Okay, actually, let's think about this. We have two things being multiplied together. So what do? We set the first one equal to 0, or the second one's also equal to 0. Okay, that first value, we can divide both sides by 4 and get that x is equal to 0. So that's one solution. And then the other one, we have a quadratic. So how do we solve these things? We set them equal to 0, and then we factor out. So what two numbers multiply to 2 add to -3? It looks like this could be x minus 2. X minus 1 is equal to 0. Boom. So then x is equal to 2 and 1. So we have three solutions in this case: 0, 2, and 1. Factoring, quadratic formula, learning and understanding quadratics, I think, are going to be huge when it comes to calculus, especially when you start trying to solve something called the critical point. So learn your factoring, master it, be comfortable with it. It's not going to go away. Okay, so now we have these inequalities. How many more problems do we have? Ooh, okay. So this next one, because these are number lines, these are inequalities, the first thing that we want to do, so let's work with A. We have x squared minus 6 is greater than or equal to 0. Okay. So a few things that we want to do. One, we got to just find some discontinuities. So we want to find when the bottom is equal to 0, because we know those values cannot exist. So if you notice, hopefully you can see right away that this factors out the bottom into x minus 4x plus 4. So now we know that x cannot equal to 4 or -4, because it will make this entire function undefined. So these are points of discontinuities. So when I have a number line, I'm going to have -4. I'm going to have 4. Those are going to be points of discontinuities. So I'm just going to have little open circles in there. Okay. And because when we're trying to find when this is greater than or equal to 0, I think we should always just try to see it as like, when is this equal to 0? And that's going to help us write our number line. So let's see, when is this equal to 0? Well, let's set the top equal to 0. And it looks like that's going to be x is equal to 3. Okay, so when x is equal to 3, we know this equation is going to equal to 0. So let's see, back to our number line. I'm going to put a 3 here. And we know that's going to be a closed circle because that is greater than or equal to. So that's going to make the equation equal to 0. Okay, so now we have to test points in between each interval here. So it's like we have to test a -5. We can test 0 here. This one's going to be tough. It's like 3.5 and x is 5 here. And just keep in mind, this isn't this is an inequality. So all we're really trying to find is when is it greater than 0. We don't really care about the value, just when is it greater than 0. So for example, when we plug in -5 to the equation, on the top, just think about this, okay? I'm just going to show you the work the first time, and then all these other times, we're just going to kind of think about it logically. So for the top, when we had that -5, we're plugging in -5 into the equation. So it's 3 minus -5 over -5 minus 4, -5 plus 4. And we're trying to see if it's just greater than 0, meaning positive or negative. So on the top, it's 3 plus 5 over, we have -9 times -1. So if that simplifies, it's 8 on the top, and then it's going to be positive 9 on the bottom. 8 over 9. We don't really care about the value. We just know that it's going to be positive. So we know that that's going to be greater than 0. So let's plug in 0. When you plug in 0, it looks like you're going to get a negative. And the reason being is because if you plug in 0 to the top, 3 minus 0 is going to be positive. Over, and if you plug in 0 to the bottom, it looks like you get -16, so that's a negative. A positive number divided by a negative number is a negative, so we know that the intervals between -4 and 3 are going to be negative. Geez, how about 3.5 though? Let's see, when you plug in 3.5 to the top, it's going to be a negative value. 3 minus 3.5 is going to be a negative value over, and then the bottom we have negative 3, or 3.5 minus 4 is a negative, and then 3.5 plus 4 is a positive. Just double checking that that is correct. I believe that is. Yep, it looks correct. So then we have a negative on the top, technically a negative on the bottom because of the product, and then 2 negatives, so that becomes a plus, a positive. Okay. So now number 5. So let's plug in number 5 there. 3 minus 5 is a negative over a positive times a positive. So on the bottom is a positive. A negative divided by a positive is going to be a negative. So we're trying to find the intervals when this is greater than or equal to 0. It's going to be these here. Okay, so then our intervals for this, our answer is going to be negative infinity to negative 4, not included. Union, 3 is included to 4, but 4 is not included. That is where it's greater than or equal to 0. Okay. That's exactly what we're going to do for part B. 3t squared minus 12t is greater than negative 9. Let's bring the negative 9 to the other side. Plus 9 is greater than 0. Okay. And in this case, I can factor out a 3. So that's t squared minus 4t plus 3. And before we even do anything, just try to, because whenever we have inequalities, it's always easiest to think, okay, when is this equal to 0? So you try to set this equal to 0, solve for your t, and then use your number line. So for the first one, it looks like I can factor this out into t minus 3, t minus 1 is greater than 0. So what two numbers set this or make this equation or inequality equal to 0? 3 and 1. So I have 1 and 3 that I have to test. Now 1 and 3 make the equation equal to 0, but the inequality was greater than 0. So we know we're not going to include those. Okay, points that I need to test. Let's do 0, t is equal to 2, and then t is equal to 4. This is kind of easy. Again, just plug them into the equation, and you're trying to see if this is going to be greater than 0. I like to plug it into this factored form. So much easier, because you can just already tell, okay, well, we have a 3 times 0 minus 3, so negative 3, and then times negative 1. That's going to be a positive. Plug in 2, so 3 times 2 minus 3, so negative 1, and then 2 minus 1, which is 1. That's a negative. And then 4, 3 times 1 times 3, that's a positive. So let's see. We're trying to find when this is greater than 0. I think we found it. We found these intervals, 0 to 1, and then 3 to infinity. So our intervals are negative infinity to 1. I said 0 to 1, but I meant negative infinity to 1. And then union 3 to infinity. That's our value. Okay, so let's go to part C. 4x cubed minus 12x is less than 0. So same thing here. Let's go ahead and factor out. It looks like a 4x, and that gives me x squared minus 3 is less than 0. Ugh. Okay, think of it like we're setting this equal to 0. We're trying to find when this is equal to 0. So 4x is equal to 0, and that's 0. And then x squared minus 3 is equal to 0. This one's gnarly. X squared is equal to 3, so x is equal to plus or minus root 3. So then we have negative root 3, we have 0, and then we have root 3. And these were equal to 0, but the inequality was less than. It didn't have an equal to, so these are just going to be open circles. Okay, so now we test some points. We have, what can we test? I'm just going to do like negative 4, x is equal to 1, or negative 1, x is equal to 1, and x is equal to 4. Okay, and again, I'm going to plug this into this formula just because it's already factored out. And again, all we really care about is it going to be positive or is it going to be negative? Okay, so let's see. For negative 4, so we have like negative 16 times When you plug in the -4 into that parentheses, -4 squared is 16 minus 3. That's a positive. So now we have a negative value. For -1, it looks like we have a -4 times a -2, it looks like. So we know that's going to be positive. And then for 1, we get 4 times -2. That's negative. And when you plug in 4, that's 16 times, it looks like it's 16 squared. So 13, positive. There you go. Okay, so where was this less than 0? Keep in mind, we're still trying to, follow the rules of the inequalities. That's going to be between this interval and that interval that I highlighted. So our answer is going to be -infinity. Whoops. -infinity to -√3 union, and that's going to be 0 to √3. All right, hopefully that made sense. But again, every time we're trying to do that number line, we just have to make sure that you find the values when it's equal to 0 and then just plug in values in between. Okay, let's go to that last one, part D. -x squared minus 9 over -x plus 6 is less than 0. Always look for those discontinuities when the bottom is equal to 0. So let's just figure that out first. When is the bottom equal to 0? That's when x is equal to 6. So we know that's going to be a discontinuity. And then let's just worry about the top now. We have -x squared minus 9. And we're trying to find when that's equal to 0 because we know we're going to test points in between. Let's factor out a negative. And what do you know? This is where you have to be very careful. We have a negative times x squared plus 9. That can't even factor out. Even if we set this x squared plus 9 is equal to 0, we move the 9 to the other side. And then we try to take the square root. It doesn't exist. It's like plus or minus root -9. We can't take the square root of -9. It's an imaginary number. So we know there's no solution here. So the only thing we have to really test is the points in between or to the right and left of 6, because that's a discontinuity. It's not equal to 0 whatsoever. So it's actually undefined. So we know that we cannot use that point. That point does not exist. Okay, so let's just test points to the left and right. So x is equal to 0, x is equal to 7. And all we really care about based off our inequality is when is it less than or equal to. In this case, we didn't find any equal to, but we're really just trying to find out when is it less than 0. So in this case, when is it negative? So when you plug in 0, looks like you get -9 over 6. So that's going to be negative. And then when you plug in, let's do 7, looks like you get like -58, I believe. So -58 over -1, that's a positive. Okay, so we know that we have a negative and then we have a positive. We're trying to find when it's less than or equal to 0. So that's going to be this interval here. So then our value is going to be from -infinity to 6. That is where the function is going to be less than or equal to 0. It wasn't equal to in any of the values, but that's exactly where it's going to be. Awesome. Okay. So I think that is all I have for today, guys. I am running out of time on my end. But again, if you guys have any questions, I'm trying to do this as more often as I possibly can. Subscribe to my YouTube channel. Please follow me on Instagram or TikTok, where I try to post as many math problems as I can for you guys to enjoy. And of course, now that I'm streaming daily, send me problems to theveganmathguy.com. There is a forum there in the front where you can just upload your pictures. And if you want to become a member, that's going to guarantee that I actually solve all your problems. So if you become a member by using my app, you get an invite as you go to my website, or you can also just find it on the link in my profile. Awesome. But again, that is all I have for today. I will see you guys real soon. Hope you enjoy your Tuesday.